Okay, so EBI 3 is to know the ionizing and penetrating properties of the different radiation. So the exam had a lot of questions about the different properties of the different radiation. And this question that you can see right in front of you is an application question where you would have to apply your knowledge of the different properties of the radiation into this particular situation. So you can see in this situation, let's have a read at it and read the question so we know what's happening here. The diagram shows how the thickness of aluminum foil is controlled. The thicker the aluminum foil, the more radiation it absorbs. The designers used a beta radiation source for this control system, and you can see that over here. Why would an alpha radiation source be unsuitable in this control system? So we're going to be looking into alpha radiation and recall the properties of an alpha radiation and see why it's not suitable for this control system. So let's have a look at a couple of responses that I've got. So the first one states that alpha radiation would be unsuitable because it can't even travel through paper. And that is correct, because alpha radiation cannot penetrate through paper, so it can definitely penetrate through aluminium foil, as aluminium foil is thicker, so this is correct. And same with this one, because alpha radiation will not pass through the foil. It isn't as strong as gamma rays. It depends on what way you're talking about. If you're talking about ionizing, then you may be correct, but in this case, it's not correct. This one states that it detects by the thicker the foil, the more radiation it absorbs, but alpha cannot go through the foil. So there's a lot of grammatical errors in this one, but they seem to have understood it in the sense that alpha can't pass through that foil. The next one is the alpha radiation source wouldn't be suitable because it can't penetrate aluminium, which is very good, and it is absorbed by the thickness of skin or a few centimeters of air. So it's very good that they've said that it cannot penetrate through aluminium, because that is the answer. Alpha radiation cannot penetrate aluminium. Now the following question was a similar question, but it was asking why gamma rays would not be appropriate to use in this control system. And the reason for that is that gamma rays will just pass straight through it. It won't be absorbed. Unlike the beta radiation will be absorbed, and it will be stopped by the aluminium foil. Gamma rays will go straight through, and alpha particles or alpha radiation will just be stopped by it. So let's explore more on the properties of these different types of radiation. So these are the different types of radiation. An alpha particle is a helium nucleus, and the charge is 2 positive because it's got 2 protons here, 2 protons. So it is a helium nucleus, and it is quite big in comparison to the beta particle, which is a fast moving electron. So the charge is going to be minus. Okay, so it's a negatively charged particle. Now a gamma ray is not a particle. Gamma wave is an electromagnetic wave, so it's an EM wave. So there is no charge with it. So you can see here with the alpha particle that is quite big. So it's almost always stopped by thin materials such as paper. And in comparison to the beta particle over here, this beta particle can go straight through the paper and gets almost always stopped by aluminium. So the thicker the aluminium, the beta radiation will be stopped. Now gamma radiation is not a particle, remember, so it would go straight through the paper and almost always go through the aluminium, and it will be stopped by the lead or thick heavy metals. So this is the penetration properties of the different radiation. So the most penetrating is going to be the gamma, and the least penetrating is going to be the alpha. Normally, atoms are neutral, and you can see there's an atom over here. This is a helium atom, and they have the same number of protons in the nucleus as they have with electrons orbiting around the nucleus. So you can see here there is 2 protons, 1, 2, and we have 2 electrons, 1, 2. So there's 2 electrons. There's an equal number of them. However, atoms can, however, lose or gain electrons due to collisions or interactions, often with nuclear radiation. And when they do, they form charged particles called ions. And this is what we call ionization. So that is when an atomic structure has been changed. So it either gains or loses an electron. So, for example, this alpha particle can interact or collide into this atom, and it can completely change the atomic structure of this atom. And what we call that is ionization, when this atom either gains or loses an electron. The same thing can happen with a beta particle. So the beta particle can interact and collide into this atom, and this atom again is probably more likely to gain an electron, because this is an electron itself, causing a change in the atomic structure. So this atomic structure will no longer be neutral. It can either be positively charged or it could be negatively charged, depending on the structure, whether it loses an electron. And when it loses an electron, it will be positively charged, and if it gains an electron, it will be negatively charged. Now, gamma rays, they are the least ionizing of the 3. So alpha particles are the most ionizing. So this is the most ionizing. And the gamma wave is going to be the least ionizing. And the reason for that is that the gamma wave is not a charged particle. So remember, this is a charged particle. It has 2 protons in it, and this is a fast-moving electron, so it is a negatively charged electron. And the gamma wave does not have a charged particle in it. It's just a wave, but it can still be ionizing.